In this lesson, we're going to discuss properties of functions. I do already have these notes filled out, so if you need to pause it so that you have time to jot things down, please feel free to do that. So first here we have even versus odd functions, and a function is even if and only if each x, y ordered pair on the graph also has the point negative x, y on the graph. Meaning it has symmetry with respect to the y-axis, if you remember that. A function is odd if and only if each ordered pair xy has the point negative x, negative y on the graph, meaning it has symmetry with respect to the origin. So looking at these graphs here, my first one was an even function because it is symmetric with respect to the x-axis. So each xy coordinate has a corresponding negative xy. My middle graph, there's no symmetry with respect to the y-axis and none with respect to the origin, so that is neither. And my last one, nothing with respect to the y-axis. It does have symmetry with respect to the origin. So each xy, there's also the point negative x, negative y on the graph, so it is odd. Next, we're going to do the same thing, but looking at equations of functions here. Notice for both even and odd, each x value originally becomes negative x. So we're going to substitute in, we're going to find f of negative x, and then see if it's the same as the original function or the opposite of the original function. So in part A here, I'm finding f of negative x. That ends up being x squared minus 5, which is the same as the original function. So it's even, meaning it is symmetric with respect to the y-axis. Part B here, substituting in negative x. We get negative x cubed minus 1. That is not the same as the original. It's also not the opposite of the original either, because this would have to be, the negative 1 would have to be negated. So this is neither odd nor even. Part C, h of negative x, when we substitute in, get negative 5x cubed plus x. Now that is the same thing as the opposite of h of x, so this function is odd, meaning it has symmetry with respect to the origin. And part D, f of negative x, plugging that in, we get that equal to the absolute value of x, which is the same as the original f of x, so it is even, it has symmetry with respect to the y-axis. Increasing, decreasing, and constant intervals. Okay, so increasing when as x gets bigger, so does y. Decreasing as x values get bigger, the y values get smaller. And constant, as x values get bigger, the y values remain the same. So here we have a graph. We're going to list the intervals where it's increasing, decreasing, and constant. So we have a domain here from negative 6, positive 6. Following the graph, starting at negative 6, I'm decreasing until I hit x is negative 4. So I'm decreasing on the interval negative 6, negative 4. And then I turn and I'm increasing, increasing, increasing all the way until I get x is 0. So I'm increasing on the interval negative 4 to 0. I then stay on a horizontal line, so I'm staying constant here. So the function is constant on the interval 0 to 3. And then I decrease again until I get to x is 6. So I'm also decreasing on the interval 3, 6. Local maxima and minima, that's just plural for maximum and minimum. Part A says at what numbers x, if any, does f have a local maximum, and lists the local maximum values. Those are asking for two different things. When it asks you just to find the max or the min, that's referring to the x value. So at what x value is there a max or a min? When it says values at the end, that's referring to the value of the function once the local max is inputted, or the max or min is inputted. So that's referring to the y value, essentially. So if you look here, local max and mins are where they are like relatively the largest. So maxima, they're largest to those compared around them. Minimum, they're smallest compared to those around them. So looking at this graph here, I would have a local max here at this hill at x is 1, and that means the local max value happens at f of 1 is equal to 2. Part B asks for the local minimum. There's 2 of them, so as I follow this along, I got my little valley here. So at x equals -1, and then again at x equals 3, these would be our two local mins. And then the local min values then, when f is -1, y is 1. When f is 3, our function is equal to 0. Intervals on which it is increasing and decreasing. So following from left and right, I'm starting up at -infinity and coming down until I hit that local min. So it's decreasing from -infinity to -1. And then from -1 to +1, I'm increasing. And then from 1 to 3, I'm decreasing again. And then from 3 to +infinity, I'm increasing. Notice we jumped from decreasing to increasing at each turning point. Okay, so at each local max or min. Those are also called turning points. So that is where I change from increasing to decreasing. And last here we have absolute maxima and minima. Sometimes that's called extremes or extrema. And it's exactly what it sounds like. It's the absolute largest point on the graph or the absolute smallest point on the graph. There's not multiple absolute max and mins. So I've just written out our absolute max, absolute min, local max, and local min here, and went through and jotted all of those down. Note that the endpoints will only be absolute max or min. So an endpoint is not going to be considered a local max or min because there's nothing else on the other side of it to compare it to here. So in graph A, my absolute maximum would be 3, 6. My absolute minimum would be 0, 1. My local max is the same as my absolute max, which is 3, 6. My local minimum is 4, 4. For graph B, my absolute maximum value is 5, 3. My absolute minimum, you might think was 3, 1, but 3, 1 is not included in the domain because it's an open circle there. There's no local max and there's no local min because they can't be the endpoints. Graph C here, the absolute max is 5, 4. My absolute min is on the interval from 1 to 2. Or you could say at the value of 1. Local max, there is none. Local min is also on the interval 1 to 2. Graph D, there is no absolute max. It goes on forever up here. My absolute min is 0, 0. There's no local max or local min. And then graph E, we might think 1, 4 is our absolute max, but it's an open circle, so it's not in the domain. So there is none. Our absolute minimum, there is none because it goes on forever down here. Our local max would be 4, 3. And there is no local minimum. Again, that is an open circle, so that is not on in our domain.